Hi everybody. Let me try to change my resolution. I think I have an issue with not sure if you guys can see it well. I might have an issue with the resolution of the screen. If so, please let me know. For now, we'll have to do with this. I do have a slight shifting with the screens. But welcome to Moment live stream for today, and today the topic is we're trying to like how Momen built its pricing calculator. So the pricing calculator can be found in a Momen pricing page in here. You can type in scenarios and you'll be able to see results. So before we dive in, let's just run something and see how it works, right? We'll do simple content site. That will open up a pricing calculator and start calculating. So why do we build something like this? One of the things that establishes trust when you're trying to, obviously I'm trying to sell Moment to my customers, is pricing transparency. Now, we want to be as transparent as possible to our users, which are non-technical founders, and we want to avoid any surprise bills because that's bad for them. They will have to break their budget, and it's bad for us because once people get a surprise bill, they're more likely to leave. Also, having something up front. Let's see what went wrong there. Having something up front that you can tell people how much it costs you is definitely helpful for them to make a informed decision. It actually increases conversion. So that is in our interest to make this thing as accurate as possible. So we do already have a pricing page. So why do we need an additional calculator? Well, Moment's pricing is based on cloud resource consumption. These are things like egress data egress, CPU usage, or like object storage usage, database size, and for things like AI points, like AI token usage. But these metrics are not natural for a non-technical person to think about, right? If I told you I want to build a simple simple content site, the one that we just typed, and which for some reason wasn't working. Let me just try it again, see if it's what was wrong with it. Let's take a look. Oh, that was not the one. That's not the one either. So we go to the resource consumption estimator v2. Let's see what's in there. That's today, and yeah, it got stuck. I think Gemini 3 Flash went crazy, but this one has completed, so that's good. So the reason we want to create something like this is we want to translate from one essentially mode of thinking, which is business scenario, to resource consumption, which then can be directly translated into cost on Moment. And the gap here is obviously that there's no direct one-to-one translation. When a person says a simple content site, there's a lot of assumptions that goes into that, and that assumption is buried in that sentence, and not obvious to a third person. Like, for example, if you would ask me that, I would have to ask you a question back. I would have to ask you, what do you mean by simple, right? Does that mean it only has text? Does that mean it has text and just one image? Or does that mean you don't allow people to comment? What does simple mean? Simple is a very subjective term. And the other thing that people typically forget about is simplicity is not the same as load. You can have a very simple website that carries a lot of traffic, right? You might have 10,000 users on a very simple looking website, like for example, let's say Hacker News. Hacker News looks surprisingly simple, right? It looks like this, but it is a very popular website. It has a lot of users, and simplicity in this case does not translate to very little resource utilization. So it's again, those are the reasons that we need to translate. And in order to do that, we want to make sure that there's no surprises. And here is one of the examples. We gave we said simple content site. Okay, so let's take a look at this estimate. It says we're going to have $80 a month in cost. Why that? It says we need to have public access, SEO, which means that it at least needs a basic plan. That's correct. It will need mostly outbound traffic in terms of cost. So why is that? It estimated 600 gigabytes of outflow every month. And let's see why that is. We're still in the process of trying to, make this thing a little bit more friendly, but you get the idea. It estimated 5,000 users, and that is a reason, right? 5,000 users would cost you $80 a month. If you reduce this to something like, I don't know, if you only had like 500 of them, then you would get, and they visit you daily, right? 500 times 30, so that's the amount of active windows that's opened, and therefore the object storage is going to remain the same, but the outbound, which is directly tied to this, is going to be something like, let's do that. So we have 500 times 1 times 1 times 10. I don't know what the 10 is. Times 30 times 300 kilobytes divided by a gigabyte. You would need 45 gigabytes per month. And instead of something like 500 gigabytes, oops, I'm sorry. Yeah, I have a screen issue. It's only recording the right portion of the screen. I'm not quite sure what's happening with my OBS, but that is that is the reason. Okay, so I should be okay now, right? So you should be able to see the entire window, the content of the window. But you won't be able to see my, actually I can do, you won't be able to see, let's see if I can do this. That's easier, right? So it'll be 45 gigabytes, and with 45 gigabytes, your cost per year then becomes, oops, sorry. Let's take a look at the computing resources. For 500 gigabytes, you pay $35, and 45 gigabytes per month, you multiply that by 12, divide by 500, well, minus 500, then minus 2 times 12. Okay, That's the amount of egress you get from the plan. So you get 16 plus. Okay, so worst case, you have to buy 2 of these 500 gigabytes. So in that case, you pay $70 on top of the 39. So your total cost becomes 30 per month, becomes 39 plus 35 times 2. That's 2 of the 500 gigabyte resource add-ons divided by 12. That's per month. So your monthly cost will be something like $40 instead of 70. Okay, so that gives you an idea how much these things cost. And now the way we calculate that is I'm gonna show you how this project is built, so you can get a sense of how we use Momen for agentic workflows in this case. Okay, so as a recap, Momen has 3 tiers. We have the free one, which is only useful for studying and prototyping. You can't even publish one project without a watermark. The basic one is what most people started off with. In this case, other than payment and single sign-on and multiple clients, you get basically everything else. So you can publish, and that's like the basics part of like I would consider this the basic plan, which is why it's called basic. And you get a associated amount of resource bundled with it. That's database, object storage, and data egress. In here, we call them outbound data transfer. We get a number of automated action flow runs. These are the things that run based off database triggers or scheduled jobs. And then you get a number of AI points, which gets converted into tokens, both input and output, and it has a different ratio depending on what model you use. And on Pro, obviously you get the payments integration, you get single sign-on, you get multiple clients, but on top of that, you get more requests per second, in fact, 5x basic, and then you get 5x the database storage, 5x object storage, 5x outbound, and 5x everything. So you get 5x resources compared to basic, and then you get some additional capabilities. Okay, and then if you run out of them, as I typically tell people, if you run out of these resources, you can always buy them a la carte, and here are the a la carte price. You can buy database, object storage, outbound data transfer, egress, or automated action flow runs or AI points individually. And if you run out of requests per second, then you can start buying dedicated instance. In this case, you get more CPU, and that would raise the requests per second that can be handled by your application. So how did we build this thing, right? So first of all, we have the UI. We actually have two versions. Currently we're on the V2. We had the V1 had some issues with the database. It was underestimating it, so we changed it up. Okay, so what happens here is if you clicked on here, it wouldn't actually do anything, but there is a countdown to start analysis. Okay, so the countdown would take you to main V2, the action flow. Actually, let's take a look at this again. And okay, so the action flow main V2, and then it's sending in the price, the project description, something. Okay, and that is where the simple main V2, that is where the simple content site comes from. And just for argument's sake, I'm gonna use something like high traffic viral event app. I'm gonna try to run it, It's going to take some time, but we'll let it run. Okay, because it has to go through AI. So first of all, we'll create a project inside our database so we can refer to it later, and then we can also store the resource consumption within it, and then eventually it gets shown like this. This is a project screen with all the values populated. So initially, all the resources, the costs, and all the reasonings are all empty. The only thing that's here is the project description. In this particular case, it is the high traffic viral event app. And then we're going to run AI, and you notice that we have two AI steps. The first AI step runs resource consumption estimator v2 step 1. It's a bit long name. Okay, let's change the name up a bit. It's kind of annoying. It's just called resource estimator v2 step 1. Okay, it's much shorter, so we can actually read it. Otherwise, in here, like, you can't even see the name. Okay, so we got step 1 and step 2. And for step 2, it's outputting, it's taking in not just the description, but also the output of step 1. So let's take a look at what step 1 does. So in Momen, you can build AI agents directly within your application, and you can define your inputs, your prompts, your context, your tools, and then structured output. We have recently changed how our prompt templating works. So now we split it into system and user, and then you can write whatever prompt you had. For people that are familiar with Momen, we used to have a single prompt template for you to just like with 3 fields. There's role, goal, and constraints. So that felt a bit restrictive, we thought. So we took that out, so you can write whatever prompt you want. But it does place a higher ask on the user, so you need to be able to structure your prompts better because there's no more guidance. We actually already have one, we just haven't released it yet. We're adding an AI prompt optimizer. So it's we're gonna have like a meta building. It's gonna be like building AI with AI. Okay, so let's take a look at here what this does. Momen project resource consumption estimator phase 1. Okay. Phase go. The phase produces system's functional blueprint. Backend capabilities, front-end views, user groups, and operational flows. Phase 2 will treat the output as a read-only skeleton and only annotate business scenes and physical resource part on top. This is kind of odd. If I didn't build this, so we'll try to change it up as we build. So this should say there will be a phase 2 that will treat the output of this phase as a read-only input to estimate. So this is a bit odd in wording. Okay, root level fields produced in this phase. Flat structure, no wrapper. You don't really have to say this, but this doesn't hurt that much. Like, we've already identified the root level fields in here. So this is not strictly necessary to do this, but you can. Okay. You can explain that. No wrapper is kind of odd way to say it, but if I were doing it, I would just remove this entirely. But it doesn't hurt, so we'll leave it here. Project description, that's whatever the user said. So in this case, let's put it in. What we had was high traffic viral app, right? So we'll run it. Let's see what it does. Things to do with it. Project baseline information user story. Before any concrete business architecture design, you must first establish the system's 2 global background parameters. That's kind of odd wording. Along the spatial and temporal axis. That is odd wording too, but I guess it's still understandable. How long the system has been running, equivalent running days, and how large the system is, and total number of registered users. What about non-registered users, right? Total number of users. So let's see what we had here. Running day, that's fine. Total registered users, it's missing unregistered users, so that is something that has to be corrected. Total number of IE, total number of users. But I won't change it up too much, because then I have to change this structure too. We'll make the improvements after the live stream. Okay. All right. So let's go back in here. Let's see. Global background parameters. That is strange wording. Equivalent running days. Equivalent running days. Assuming the system runs continuously at its current activity level, how many days of continuous operation are required to accumulate the physical data volume produced over the past 13 months? Why 13 months? Also, this is a strange sentence. I don't know how this. I guess the person developing this used some AI to do it, but it's a very weird AI. It's very strange wording, but it kind of get it. Okay, so it's looking at I would say at a constant activity level, how many are required to accumulate? The physical data produced over. And why 13 months? Why not 12? This is a very strange thing, but I think the idea is if you have a cold start of a project, your data will continuously increase. You need to account for the fact that the activity level was not flat, right? It's a steadily increasing function. So it's a very strange way of putting it, but let's leave it at that. I'll check with the engineer. Decision rules for the equivalent days value. Stock migration system. Fully loaded. What is a stock migration? What is a stock? I don't know what that stock migration system is. Fully migrating. Okay, I think migrating from existing systems. Constant work. Basically, we just say be equivalent to the actual number of days. Due to constant and existing load, the equivalent days should be the same as actual running days, actual operating days, i.e. 365. Early burst than plateau systems. Okay, rapidly reaching a ceiling. Pick that. Okay, so that means it's when it starts, it's a bit small, but then it quickly reaches peak and then plateaus. So you get like a. Okay, so it's assuming that within the 360 days, you spend enough days with a low load that it counts for like 50 days missing. Standard linear growth. Okay, so this is linear growth. That's I mean, I would never say pick between. It's kind of useless. And let's just write 275. It's kind of useless to give it a range. 225. Recent burst system cold start trough for most of the past half year. Huh? That is a very strange thing too. Total registered users, total number of accounts existed in the database under stable operating conditions, the active user count under specific concurrent scenes is fully driven by those scenes. That's kind of stupid. That I don't know what this means. This is a very strange wording. This field only serves as a baseline for database accumulation. Okay, so we're going to be using total registered users in order to deduce how much database there is. But this is strange English. I don't know what this is clearly written by some AI. I just don't know what AI. This is very weird English. Output requirements for global blah blah blah. Field 1. So this was already done, so I don't know why it's written again like this. It's not useful because it's already in here. It's already in here, so you don't really have to write it. It doesn't hurt again, but it's kind of dumb. The project is okay, so it explains. And why 360? Shouldn't it be 665? So odd. Total registered users. Sure. User stories. So not just, we don't care only about how many users are using it. We also care about how the user is using it. So we're gonna design user story. We're gonna ask AI to design user stories. User must be strictly grounded. The user provided project description. Only cover features explicit stated. Okay. And necessary default and necessary that are necessary for the given project type. Default and necessary. That's again some strange English. Do not assume, extend, or introduce advanced or optional features the user did not mention. I mean, this kind of contradicts with the one that's before. The goal of users to faithfully reflect the actual requirements of the current stage, not complete or mature product vision. Okay. So this is to prevent feature creep from affecting the estimate in the end. We used to have a thing here for you to update. There's a text entry box for you to give additional feedback to the estimate, especially like including the use cases that wasn't initially included in the project description. But I think for V2 that wasn't included. Complementary row alignment principle. When a right side user store, what is a right side? Oh. Okay, I see. So it's saying that if somebody writes into a system, somebody else has to read from the system. I mean, it kind of makes sense. It's strange wording again. This whole prompt has to be like properly cleaned up, but it's for now. I'm sure an AI would understand this. It's just very disgusting to read. Typical closed loop pairs. Okay, custom place order. Somebody has to view the order. Obviously, blogger writes particles. Okay, employee submit application. Okay, sure. Data origin complete principle, completeness. Any data that can be queried and read in the system must have clearly defined creation and write path. Okay. So again, that's the same thing. So if there is some data in the database, it must have come from somewhere, right? So that is so don't like invent strange like dangling data. Okay, so that's cool. I want to build a SaaS product. As a user, I want to do these things. That makes sense. E-commerce web platforms, okay. And this is unnecessary too. No need. Okay, then how long is this? Let's see. That is very long. Okay. We're not going to review the whole thing, but you get the idea. It's very detailed, albeit very strange English. But the idea is you want to make sure the AI behaves exactly what you like, exactly the way you want it to behave, rather than let it take full reign. And also, for things that the AI typically would have oversight, for example, it might miss a write user story when a read exists, or vice versa. So these are the things that tries to make the AI's response more complete. Okay, so let's take a look at what this says, right? I'm gonna find myself a JSON viewer. Ah, works. A format. Can this thing be bigger? This is a very strange JSON viewer. Click to test it out. That's not very useful. This is the one that I usually use. Oh, it's now redirected. That is, okay, here we go. Something that works, finally. All right, format JSON. Okay, so this is good enough. We'll full screen this. Okay, so we have event discovery page. We have a few views. We have user flows. We have user groups, user stories, backend design, register users, and equivalent running days. A viral application characterized by sudden bursts of activity, while physical existence might be longer. The bulk of the data is generated during active campaign windows. Okay. Therefore, an equivalent 120 days is shown to reflect several high-intensity events over the last year. All right, fine. Bursty stuff. So the data is generated in bursts. We're assuming we're looking at 500,000 users because it's a viral app. Maybe you want to go higher, but 500,000 seems fair. Backend design. We have some APIs which are going to send. So all the backend stuff are directly found in Momen. So you get APIs, AI agents, data model, and action flows, things that will consume your resources. Send verification, SMS, looks fine. Event copy optimizer. All right, that might be used when you're creating a new event. Data model, you got different tables and different fields. Okay, so let's see. It doesn't have a table name, which is kind of unfortunate, but I guess it's not too bad. Oh, it does have a table. Users. Actually, it's just a count. Okay, it thinks it has two fields. In fact, we have probably 10, but doesn't hurt too much. That's not where most of the data goes anyways. Fields, you got events. All right, so this is the going to be somewhat of a bigger one. We got the title, description, cover image, stats. Stats might not be a string, but again, we're being fairly loose here. Participant count, blah blah blah. And this one, I guess, is participation. So let's open it up. Yeah, event participation. This is going to be the biggest one, right? Every time anyone signs up for any event, we'll have an entry in here. And you got relations and action flows. We have a participation processor. It's gonna verify eligibility and blah blah blah. And then we're gonna look at the events and then make sure their status gets updated. Okay, so that looks cool. Now, what do we do with this? Again, if you look back to here, it goes to step 2. So step 2 is this guy over here, and we're gonna use what was it called? I just pasted in the entire output here, and then it's a high traffic viral app, right? And let's see how this thing's constructed. The same model applies here, because if you look at it, we have structured output, no tools, no additional context. Everything's coming from the input and the prompt template. So this one is building the system skeleton, building on the system skeleton already produced. I mean, it's kind of strange that it's calling it skeleton JSON. All right. I mean, I don't know what's the obsession here with skeleton, but okay. Already produce the phase calibrates 2 things: business scenes. I think it's trying to say scenario, but okay. Within which time windows, by which user groups, running which operation flows. Okay. Triggering which front end. Okay. Again, very strange English here, but okay, it makes sense. Physical resource consumption parameters, database capacity. Okay, so this is where we start estimating actual resource consumption. And one thing you should notice that within here, we do not have price calculation, right? Even though we have all the pricing information already, because we own the product. That's because AIs are not good at doing math. Right? Don't ask AI to do math. Just like if you were to ask an accountant or your finance guy to do some computation, you give them a calculator. You don't, or Excel. You don't ask them to do it in their heads. It's a bad thing. For humans, just bad at it. So we need a behavior pattern, database volume, object storage, AI points. Okay. I think behavior pattern is going to tell us how much outflow there is. And also it's going to tell us the requests per second. That's where we plug in the description, the skeleton, that doesn't really matter. Now it's like explaining what came out of phase 1. Here's where we give the skeleton JSON, and then now it's getting the business scene. So let's take a look at what it does, right? We're not going to go through the entire thing, but the gist is that don't get AI to do computation. Try to break down things into steps. That's very similar to how you would approach an experienced but somewhat intelligent person. You break things down for them into smaller steps to make sure that like the tighter you control them, the more the fewer surprises you get. Fewer surprises, both in the good surprises and the bad surprises. In this particular case, we don't want any surprises. We want it to be repeatable. We want it to be conforming to our view of the world, have the estimation to be as close to reality as possible. Okay, so we have this guy over here. Let's take a look. Gonna close this, paste in a new thing. JSON viewer, load, whoops, format JSON, and now we're looking at, okay. So there will be no image inputs for the optimizer, okay? No video, no output video. Input is probably going to be 1500. And strange thing is, why characters? Shouldn't it look at tokens? But we'll see. And why English? Couldn't be, I don't know, Japanese or Chinese. Some things that can only be answered by the actual implementer. Okay, object storage. We get only cover images. In this case, it did not consider any of the users' avatars, right? So that might have to be changed. So in this case, how many cover image each event would have a cover image, and in this case, is looking at 400 kilobytes, which is okay-ish. It's on the smaller side, but if you stick to WebP, it's doable. Retention days. Okay, so if that was to be deleted later, 120 days, maybe you want to retain them forever, right? So most of them are retained forever. You don't bother deleting them. Okay, so that's more or less okay. I wouldn't agree with the retention stuff here, but that's that. Database volume. Okay, so we have 500,000 users. That's as expected. And then you have 1,000 events, which kind of makes sense. And they don't get updated almost at all. Right? They don't ever get updated by the number of users, or users don't really change unless you have like a two-sided thing. But in this case, I guess the idea is you have an admin that's producing these events. And then, yeah, this is strange too. Like, I guess the whole thing was AI thinks that things get deleted, but usually things just never get deleted. Event participations, how many do we have? Every month, every user participates in 8 events, which is not few. Most people won't attend 8 events, but okay, so that's fine. Oh, I see. This is coming to here. I don't think these should be mixed. These should get mixed, actually. But, okay, that's... Such is life. There might be a better way to estimate this, but this is not too bad. Behavior pattern, you got a viral spike. So anonymous visitors is one group of people, and they'll share once. They'll view 80% of them will view event details, and then 100% of them will look at active events. So these are 2 different API calls. So every time 45,000 of them will show up. That's quite a lot of people. And engaged users are the ones that are always there. So they always look at event details, and they almost always participate in events. They also look at leaderboard. All right. So in this particular case, in a viral spike, you have 1,500 of them are like engaged people, and then 45,000 that are less engaged. Okay, and then every time that happens, it lasts for 5 minutes. And every day you get one. Okay, fine. So this is very popular stuff here we're looking at. And then here it's just looking at random stuff. So you can see that, oh my God, that's 105,000 people looking at browsing stuff and doing that every day for the duration of the day. Okay, so it's only accounting for 12 hours, looking for the worst case. Managing the campaign doesn't really take that much. Okay, so now we have all these cases, but that's still not where we need to be for calculating the actual numbers. So what happens then, right? The next step, actually, let's take a look at what happens here. I did run, but I went away. we run a resource v2 action flow. So those are just, I think that's a piece of code. Yeah, it's a piece of code. Here we're looking at a bunch of math. And if you're trying to do math, just don't bother too much with no code configuration. It's much easier to express them in code. Plus, you can use this thing to ask the AI to build it for you. So it's not as painful as you think. Like in this particular case, I will give the step one JSON string here. I will just tell it step one JSON string example blah, and step two JSON string blah, and then what I want to do. Explain my logic in plain language, then you will get your code. In this particular case, you have things like formatting, so to make things more legible, and you have the size of different database fields, some constants, and a bunch of that. Eventually, unify items, calculate all resources. I think calculate all resources gives you different steps, and for each step, it's especially sensitive to like the business scenarios, and then for RPS and outflow, and then for the other types like database consumption and object storage, it's usually concerned with the number of users and how they contribute to the accumulation of data. But everything here, let's ask Gemini to, what is this thing doing? And I will just use Flash to make it quick. So we've gone full circle. We've started with intention to code. Now we're trying to get code back to intention. Okay, automated schema. Okay, concise, intuitive answer. Infrastructure cost and capacity planner tailored for Momen apps. Yay! Fantastic. It builds physical database schema. It simulates real user behavior, calculates physical storage and performance. Bottom line, lets you answer the question like, if I get 10,000 active users next month, will my database crash and how much storage it consumes? And what will my hosting bill look like? That's exactly what it does. Okay, so after that, there's one more step, which involves an AI. And that's this plan here. That's for picking the plan. This one is much easier. Plan v2. I mean, it's still kind of long, but the output is going to be very simple. It's what feature you need for a moment, which determines the minimum amount, the minimum plan you need. And then that's a min plan. That's the one here. And that's the only thing it does, because we don't exactly know what features they need until we've analyzed everything. So the only thing it outputs is like what plan you need, and that's the minimum. That's the minimum for your monthly cost. All right, once that's done, now here is calculating the price. This is again going to be code. So we're gonna just go in there, and then we'll do the same thing for Gemini. Where's my Gemini? What does this do? Intuitive answer, concise. Okay, and analyze the backend blueprints, UI views, gets the peak RPS. That's what determines what you need in terms of both plan and if you need dedicated instance. Database size, object storage, monthly outflow, assembles the input, simulates the behavior, applies physical facts, tracks hidden costs, and eventually you get costs for everything. And you have this cost results stuff here. Okay, so that's basically what goes on, and then you update everything accordingly, and that's it. Now, the takeaway here, I think, is you want to break down a very complex, well, couple of things. First is in the motive, why you built something like this. It's to translate between different languages, translate between non-technical business result oriented language to resource consumption in a computing context. And then with that, you can apply fixed logic so your user don't have to answer a bunch of questions before they get a rough answer, because that's what people want. Give me a rough idea of how much money it's going to cost me. And if you ask an engineer that, they typically will not give you a straight answer, because we don't, like, as engineers, we don't want to give them estimates without being specific on the assumption. And again, the assumptions should be exposed to the user so they can challenge those assumptions, right? We're not trying to hide anything, but we don't have the luxury of obtaining all the necessary information before answering the question, because the user doesn't have that patience. So that's the motive. And during implementation, we have noticed a couple of things. One is we break down the steps. We don't we don't ask a single AI to do too much. We break it down, and it also makes it easier to optimize your prompts and your agents. And secondly, structured output is very important. Without structured output, you won't be able to do much. You won't be able to use JavaScript to process the output of the AI and eventually get your answer. And a side note, which we have probably discovered, is that even if you have broken English or broken language in general, I mean, like, I don't know how this language even gets generated. It's really strange English, but AI seems to be very immune to that. Like, if I were reading, I would read halfway through and go crazy, but AIs don't have the choice of going crazy, so they're able to produce reasonable answers as long as, like, the words are, they don't contradict each other too much, and you can choose like strange wording, strange expressions, but that seems to be fine. And for actual calculations, computation, don't rely on the AI. Let the AI do the deduction, but don't let the AI do the computation, because that's not what they're good for. They will make mistakes. It's very difficult to track down what went wrong. So when you could end up with a scenario, if you use all AI to do that, is your end result, the number, the cost, does not agree with your business scenarios, right? So that can happen, and at that point, you have to then go in there and figure out like what the hell is going wrong. In this particular case, the only thing that's coming out of AI are these assumptions. The assumptions are coming out of AI. All the numbers are coming from code or whatever fixed logic you have. Cool. So, couple more things we're gonna try. We have another 5 minutes. We're gonna try to look at the costs on Moment, do other things. Let's go back to the Viro app. I'm gonna do the Viro app. It does not always succeed. The reason it doesn't is Gemini, or whatever AI model you use, it does not guarantee success. In our particular case, it was going crazy over this guy here, for example. It just went completely nuts. And then if you look at what it did, I think it didn't do anything useful. It just completely failed. We asked it to generate a structured output. Sometimes it will end up repeating itself and go completely crazy. While we're waiting for this, let's run a bunch of them. So we'll see what the costs of them are. I have prepared a couple of examples. Oh, and I noticed I forgot and lastly, what we're gonna ask is how much does running the calculator itself a moment cost? It is going to be very difficult to do. I think we haven't fully incorporated AI. Oh no, we did. We did. Running the pricing calculator, a pricing calculator for moment.app, the no code full stack application dev platform. We did not inject anything moment specific into the prompt, so we'll see what it does. And I know that we have a shift in layout. It's kind of unfortunate. I have to shift it back. Okay, so that's running, that's running, that's running. I don't know why this thing is not running. Oh, that's just because high traffic viral app. Yes, okay. Okay, we should see 4 of these guys running in here. Oh, we have a few that's completed. That's good. But we have 3 steps. Remember, we have step 1, step 2, and then we have like a plan picker. Okay, we have a couple that's completed. Still doing it. How many do we have here? That's 57. That's just one of them complete. Okay, this one's completed. So what is this? A B2B internal tool, and the cost is $250 a month. Most of the costs again is actually single tenant. Why is that? Okay, so let's take a look. Oh, that is a lot of people. So 3,000 people. You're looking at a very large system here. So for 3,000 users who visit almost visit steady state workday collaboration, 22 times a month, each time lasting the whole morning, I guess, with 3,000 users. So everybody is logging in. During that scenario, you do this core post task comment thing, running this task collaboration flow. I guess you post and read, and that's invoked. Oh, there's also AI involved. So you invoke AI 13,000 times each month, and every second, 4 requests per second for a particular scenario, and then peak concurrency 42 requests. And why is that? So we said people times triggers per over time, so 5 triggers over 730 seconds times peak amplification. Okay, so you do one API call, a single one, you keep calling that 5 times over I don't know, this is 10 minutes. That's not 10 minutes, that's 15 minutes. So for every 15 minutes you would do something 5 times, and then during the peak hours you would do that 4 times as much. So during the peak hour times you would do 20 updates per 15 minutes, and that translates to 42 requests per second for all 1,500 regular members. And those operations will continue to accumulate database records, and that is the estimate is that you have 500, you have half a gig of database usage, and then almost because of a lot of updates, there's a lot of index use, and most of that is taken up by comments because that's the most common use case. Object storage is going to be fairly cheap because you post usually just text. Outbound traffic is high, but not that high for 3,000 people. In a very highly active 3,000 people. Monthly AI points, we're going to be using, I don't know what model. Oh, using a very cheap model. But if you are using GPT-5 mini, the cost of this will probably go to something like, you probably add like 2 zeros there. So you will have to pay a lot for AI. By a lot, I mean, instead of... That is odd. 6 million, that's wrong. You don't have to buy anything. This is a wrong one. Right, because you only spent 140k, but if you added 2 zeros there, you would have to buy 2 of these. It will be $20 per month additional cost in tokens. Okay, so that's a very busy one for an internal tool. This one is what? What is this? E-commerce. And serving how many people? 14,000 people. Like, usually, again, usually when people estimate their cost, they don't use numbers like this. But okay, this is what AI decided the typical money-making e-commerce site would cost. To serve 14,000 people costs you $600, and most of that, again, is coming from outbound traffic. And you do have to buy a single tenant because you're looking at tens of thousands of people. And peak RPS is 42. That's strange. This one, they seem to love this 42 number, but okay. Not much database, lots of images, not that much. Lots of outbound, people look at images. Not much AI, mostly just outbound traffic. That's something that you can't really get away with because Amazon's going to charge you, we're going to charge you. And what is this? This is a... Okay, yeah, that's the one. The pro requires long-term access. Standard business day usage. I forgot what this was. I think that was the... Let's see. That's probably the Momen Pricing Calculator. Yeah, that's the one. That is the one. Estimated and review costs carried out by 800 anonymous visitors. Okay. And 200 registers, 1,000 people. AI is involved 2,000 times. Okay, so that's not bad. Because this is estimating that not that many people is using this calculator, so there's no image involved, so that's that. Peak concurrency isn't very high because people wait around. Like, we have been on this website, we have barely made any requests. It's cheap because it's 3 Flash, but if we were using something else, it would be 100 times more expensive, but still reasonable. That would be like 3 million AI points, which is less than $10, like $5. Okay, so that sums it up, I guess. We've looked through how a pricing calculator runs and is constructed, and then give it a try, see how much it costs you to build something on Momen. You can put in numbers there that will help the AI a lot to give you a better estimate right? If you are only, serving, you're building a homework grading system for a school of 500 people, well, then that'll be much cheaper than if you just put, say, I'll do a SaaS for homework AI grading, because then AI would probably guess you have like, I don't know, 10,000 people or something. Okay, thank you very much. Next time when we do live stream, I'll try to fix my screen. I don't know what's going on with my screen. It's offset. And yeah, see ya.